Hey everyone, welcome back to my channel EduVibe. Today we will start with another topic of forces and fields from the grade 12 physics, which is electrical fields and the vector addition. So in this topic, we will know about the vector addition in this. As we do in momentum manifolds, we do some y component s component vector addition type, and when we do Coulomb's law also in this unit, we will do vector analysis. So in this too, this is like the important long questions you given, what a written response you get from that topic. And like this is a very important topic, and I will tell you how can you do this. Like if you know about the electric fields, like if I review from that, that if you have a source charge of positive and your test charge is remain positive always, so it goes away. It goes away, and if you have a negative source charge and the test charge is positive, it goes towards it, and the electric field also goes towards this, and this goes away. The force also goes with the electric field as it goes. So that's all the thing you have to know about when we're doing this, because we do electric fields and the vector addition. So let's move directly to the questions, because the questions are important. Like we have not nothing like very much theory in this. So let's do this, and the theory we know that this one theory you have to know. So, the first example is a simple one. So, two positively charged spheres A and B are placed as shown below. The charge on sphere B is 3.50 10 raised to minus 7 coulombs. The electric field strength at the P due to the charge A is 2.19 into 10 raised to 6 Newton coulombs. Determine the net electric field at P. So, when you do this type of question, so always you get some diagram like this. Sometimes you have to make that diagram. So in that type of question, when you get the P point, and always you get the P point, and that P point always your test charge. It is a test charge, so it remains in positive. So they mention that P is the test charge. You have to know this is the always the P is the test charge and as the charge of positive. So here they said that the charge on sphere B is this. So it's a positive charge. So this means your sphere B is this. So this has also a positive one. So that's clear to you. The electric field strength at P due to a charge at A is 2.99. So we have the electric field strength of this of P due to the A. So this is P due to the A. So this means we have this also positive. So this is positive because you have this electric field strength is in positive, so it remains that positive. So for this type also always have to make the free body diagram, as I told you when you do Coulomb's law vector analysis. So in this, so if you this is your P point and that B is the positive, this is the positive is the source charge and this is your test charge positive. So this goes away from this. So if this is away from this, so your force B, which is T. So T is a force tension of on B. So this is type we have to write. So and for A, this is also positive, and if this goes with this is the source charge of positive again, so it goes away from that. So it goes away from that. When you go away, so it goes away from that. So like this, you have to make this free body diagram. So all the details you have given on the right side. So you take right side as positive. So your right side is as positive and your left side is remains negative. So now you have to do what? You have to find the net electric field at P. So find that you have to find that electric field at B, because electric field at A, the charge P due to the charge A you have, which is 2.9 10 to 6, but you want for B. That electric field strength at P due to the charge B you have to find. So to find this, we have to know that electric field, as we know that we do that formula to find the electric field, which is KQB, because we find the QB, and R square B. So this is the formula you have to know. Find for B. So let if you're on B, K has a value of 8.99 into 10 raised to power 9 Newton meter square upon Coulomb square. QB is equal to 3.50 into 10 raised to power minus 7 coulombs and divided by 0. So you have that 5.40 centimeters. They should be in meters, which is 0.0450 meters. So 0.0450 meter, and we have to do square of this. When you do square, when you solve this, when you divide this, you get about 1.079 into 10 raised to power 6 Newton coulombs. Now this should be in positive or negative. So your B is goes on the left direction, and we take left as negative. So this should be in negative. So this is electric field is in negative. So now you have to find the net one. So for the net one, it's all over there. EA plus EB. So EA you have about 2.19 10 raised to power 6 plus minus 1.079 into 10 raised to power 6 Newton coulombs, and that E is equal to 1.110 into 10 raised to power 6 Newton coulombs. And when you do the proper series, you want three series, so 1.11 10 raised to power 6 Newton coulombs. So this is your net electric field at P of 1.11 10 raised to power 6 Newton coulombs, and this is in positive. So this means this is in the right direction. So that's how you have to find this. Now we move on to some like like higher level of this now. So this is that. So from here you have to determine the electric field at P, which is net, if sphere A has a charge of 2.0 microcoulombs and sphere B has a charge of minus 3.0 microcoulombs. Now you have a different kind of diagram. So this P is again positive. This is positive charge. This has a negative charge. So for the free body diagram, how can we make that diagram? So for this is in positive, and this is also positive. So P, if this is your P point, this is your P point. So this positive goes like this, away from that, and this towards this, like this. So you take this type of thing, and you have the south direction, over there have your west direction. So you take both direction as positive in that case. Now again you have to find the EA and EB. You have the directions in this, and you made some right angle triangle in this type of. So you have to find that theta 2 and the magnitude of the E, which is electric field. So you can't do the like when you type do like this type of this straight line anything, just like the straight line vector addition. So you take only like EA, EB, and you have to plus this to find the net one. But if you get this type of thing, the right angle form, or when we do the S and Y component one, so you have to find the angle and the magnitude too with that direction. So the west and south is positive in that case. So let's find first EA. So EA is equal to KQEA plus R square A. So find EA is equal to 8.99 into 10 raised to power 9 Newton dot meter square C square multiply by 2.0 into 10 raised to power minus 6 coulombs. So micro has the value of my 10 raised to power minus 6 coulombs. And for EA, so from this to this you have this direction, which is 0.0040. So 0.040 meter square of this, and you get EA about 1.123 into 10 raised to power 7 Newton coulombs. So this is very positive because you take south as positive. So this is positive and other one is also in positive. So this is your EA. Now you have to find your EB. So it's K QB RB square. So to find this, so again K value you have 8.99 10 raised to power 9 Newton meter square C square. For this you have that negative positive just to find that what charge going on is towards or it's away. When you use the formula you have to take this in positive. So whatever the sign is you have to take this in positive. Again micro charge of 10 raised to minus 6. Now from this to this you have that this R, which is 0.060 meters. So 0.060 meters and square of this. So you get EB of about 7.491 into 10 raised to power 6 Newton coulombs when you solve this. So this is your EA, this is your EB, both in positive. So for making the resultant vector, so it's easy for that. So they go to respective directions. So for the resultant, so first one goes to south, other one goes to west, and you have to find this. So this is your E, this is your EA, this is your EB. This is your theta and this is right angle. So to find the magnitude of this, you have to just do EA square plus EB square. So you have to put the values in. E has a value of 1.123 into 10 raised to power 7 Newton Coulomb square plus 7.491 into 10 raised to power 6 Newton Coulomb square. So when you find that, you get about 1.3505 into 10 raised to power 7 Newton coulombs. For angle, you do theta is equal to 10 raised to minus 1 EB upon EA. Have to put the values in, which is 7.491 into 10 raised to power 6 Newton per coulombs. And you have 1.123 into 10 raised to power 6 Newton coulombs. And when you solve this, you get about 33.69 degrees. So this is the south of, no, so this is west of south. And when you have to put that all together, you get in two say this, so 1.4 into 10 raised to power 7 Newton coulombs. And we have 34 degrees west of south. So this is your electric field. That's how you have to find this when you get the more complex one, that type of that. So always you can see that P is in center. Here the P is in center. And this again P is in center. But if that P is in not in center, like in either side of the space, like this one. So when you this type of question, here's the thing starts when you calculating your vectors. So in that question, you're calculating the vectors now. So in that case too, your P's remains positive because you want to still make the free body diagram in this. And in that case, you didn't like right angle free body diagram or the straight free diagram because this torsion depends differently now. So I have to find the net electric field again. Charge A is minus 4.0 microcoulombs, the charge B is plus 3.0 microcoulombs. This means that A is in negative, B is in positive. We have that R2 for the both. So first step is to find the E and B. So find EA and EB is different in that case. Because to find the EA is directly, because let's find the EA first. So let's find over there. Then I explain you the question again. So EA is KQA upon R square A. So this EA is equal to 8.99 into 10 raised to power 9 Newton meter square, Coulomb square. QA you get about 4.00 into 10 raised to power minus 6 Coulomb. Not a negative of this because we take for negative for all directions. And that EA, so EA is 5.0. So this means your in meters you get 0.050 meters. So 0.050 meters square. And when you calculate your EA, you get about 1.438 into 10 raised to power 7 Newton coulombs. So this is your EA. But for EB, so now this is positive and EA is over there which is negative, so it goes away from that. So now it goes towards it. So you go towards it like this. So this is your FET. But for EB now. So your positive is here and your net positive is here. So it goes away from this, but you have to take from that like this, like line angles. Not this here, this and the straight line. This is now in the opposite time lines of this. So this means this goes away, so it goes like this. They made like type of obtuse angle, and this is your F B T. So what's the difference in this now? So the difference is that now your R should be this one, not this one. To find that R, if this is right angle and this is like straight line goes towards this, so this means you have to find that R. And how can you find the R? So you can find the R like 0.050 meter square plus 0.050 meter square. Like this you have to find now. So this value you have to directly do this and get the calculation done, and then you get your R. So I get to put that thing in the formula. So when we do EB is equal to 8.99 into 10 raised to power 9, I'm directly leaving this. You know this is the same formula we use. And your Q, which is 3.0 into 10 raised to power minus 6 coulombs. And your that R like this. So it goes like this, which is 0.050 meter square plus 0.050 meter square. And this whole power is also square of this. And when you calculate this, if I calculate the denominator, then solve it, you get about 5.394 into 10 raised to power 6 Newton coulombs. So in that case, this is your east type of direction, so you take east, and another one you take north, so both are in positive, and you both is in positive, so that doesn't mean that what is this. So this is the half part we have done, E and EB. Now we have to find the components. You can see from here that your, if it is this vector A to P, this remains in straight line, this remains in X component, but that B is not in the right direction, this is in this direction or in this direction. So this has the two components of this, so X component and Y component, and you have to find the both component. So for that term, we have to find another vector, small vector for only the B1, not the A1. A is the great one. So we have to find that what vector you get. So for that vector you have to make. So you can see that if we extend that line, if we erase this, and if we extend that line, so you get some X vector over there, the X vector, and that you get some Y vector. And from here you get this one. So let's make that type of diagram in this. So this is your X vector, which is EB magnitude of X, and this goes out over here, and this is EB, this is your Y, and this is your EB final. We have to find magnitude. So that's how you get. And for X and Y you have to get. Now what's the right angle? So you have to find that angle. So you all know that this is a right angle. If this is 90 degree, so if you break down this, so 90, so it's 45 degree and 45 degree. Make sure your sum of this is 180, which is 180. So now EBS, first we get the X component, and you see that as it goes to the opposite direction, which is west, and we take east as positive, so we take negative. And what is your EB? You get this one, so you have to put this, so which is 5.394 into 10 raised to power 6 Newton coulombs, and you have to find this base, so you get cos 45 degree, and this, when you solve this, you get a negative of 3.814 into 10 raised to power 6 Newton coulombs. For EBY, for EBY is remain positive or there is north direction. So 5.394 into 10 raised to power 6 Newton coulombs, and now you get the sine 45 degree. So this one, so you get about 3.814 into 10 raised to power 6 Newton coulombs. So this is another one, and now you have to find the total one. So for X component total, for Y component total. For X component, you get EA, because that EA remains your X component. This is your X component 2, which is that type. Meaning this, so EA S. So you get this value directly. Plus you have to take this EBS. So when you do this, and make sure you put the signs that in, because the sign is matter over there. So 1.057 into 10 raised to power 7 Newton coulomb you get, and the plus minus goes to minus. So this is your EX. For EY, you get the same value as EBY because you don't have any value for EAY. So that EY, you have about 3.814 into 10 raised to power 6 Newton coulombs. So that's your EX, that's your EY. Now you have to find the vector and then the magnitude and the value of theta. So both you get in positive. So your respective directions you take. So your east direction is EX. Your this direction goes to EY, and this direction goes to E, which you have to find. This is right and this is theta. So to find this, EX squared plus EY squared. So I have to put the values in. So which is 1.057 10 raised to power 7 square plus 3.814 10 raised to power 6 square. And when you calculate, you get 1.124 into 10 raised to power 7 Newton coulombs. And for theta again, so tan negative 1 EY plus EX. So EY is about 3.814 10 raised to power 6, and this is 1.057 10 raised to power 7. When you solve this, you get about 9.8 degrees, and this is now north of east. So you get into 3 this, so 1.12 10 raised to power 7 Newton coulombs, and you have 19.8 degree north of east. So this is your answer for your actual Markov question. So this is your net electric field. So that's how you can find that lots of work in doing that. So that's a question you get in written, and there are more type of question you have. So which were discussed in practice questions or in diploma questions when you do. So that's all for this. So this is the last type of question when you get the long line of questions. After that, you just do the formula and then the short questions you have. And yeah, so S component Y component is the last part of this unit. After you get that like S and Y components, that is. So the next topic we will start with the potential energy because we do the electric field. Now we do the electric field and potential energy through. So this is like one of the easy topic when you do. So in the next lesson we will do the topic. So learning by self with EduVibe, learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till then, stay connected with EduVibe.